Hey, thanks everyone for joining us. Today we're going to be presenting on governance on Rails for FinServ. And it's really about this idea that, delivering product to market isn't as easy as just writing the code and clicking the deploy button, especially when we're working in these high compliance environments, right? There's a lot more that needs to happen, right? It doesn't matter if we can ship code 100 times a day, right? If our compliance teams can't keep up with that, right, we're shipping non-compliant software, or we have to make security assumptions about the trustworthiness of that software. So with me today, I have John. He is our Director of Open Source and our product lead for the commercial product that we're developing. He's very involved in the CNCF open source community, focused on software supply chain security. Previously, before TestifySec, he was at VMware, where he led a lot of their product security efforts with the VMware Tanzu platform. Myself, I am one of the co-founders here at TestifySec. I am a veteran and as well as spent a lot of time working with the Department of Defense, as well as financial services organizations, really trying to understand, hey, how can we get software into production faster where it can start having impact on business goals or mission impact. So at TestifySec, we're the maintainer of open source project called in-toto, and there's two sub-projects underneath that called Witness and Archivista. The in-toto project, that is it's a larger project started by NYU. So we've developed some application or some projects underneath that that are really specifically tailored towards implementing that specification for enterprises. We've contributed to two very influential papers. One is a CNCF software supply chain best practices paper that was published a few years ago after the SolarWinds attack. And there's been a lot that's come out of that, including the secure software development framework published by NIST. That was the best practices paper was actually cited 12 times in that. And then earlier this year, NIST 800 tool 4D was published by NIST. And that describes how to perform DevSecOps in a microservices environment, right? When we have 100 or hundreds of microservices, it becomes very difficult to enforce software supply chain security. So we have some methods for doing that in there. We have many customers across many different verticals. Some of them are within FinServ. We're helping a tier 1 banking organization increase the auditability and veracity of their software development pipelines. So what's the problem here, right? Why do we even care about compliance? Well, I really like this model, the systems model. This is Rasmussen's failure model, right? So when we're thinking about financial services, right, we have some pressures, right? So we have a few gradients, right? We have this boundary to economic failure, right? That means we have to ship our product to market, otherwise we're not going to get any revenue, right? So we have a pressure to move faster into market with that. And then we have this gradient right here, right? This is our boundary to unacceptable workloads. We can only push our developers so hard, otherwise their code is going to be error prone, right? Or it's just not going to do what we want it to do, right? So right here, and if a lot of you here are involved in security and compliance, right? This is the gradient where you're applying pressure, right? And if we don't have that, what happens is our systems fail. It's because our developers are working too hard, or we have too much financial pressures on us, right? So we need something that stands in the way of that, something that protects our production systems from failure, right? And this is why we have compliance frameworks, right? And this is that gradient, right? These are the tests and the cybersecurity controls that are required to get your software into production, right? But the problem is that this gradient right here, developers can ship 100 times a day. Compliance engineers, compliance people, right, maybe at the best performing organizations, they might only be able to do an evaluation once every 30 days. Right? So DevSecOps is supposed to solve this, right? We're going to just continuously deliver everything. We're going to define everything in a pipeline, and all of our problems are going to be solved. Well, in practice, this just doesn't happen, right? Because we have issues with DevSecOps. First, we have limited traceability, right? What actually happens in those pipelines? What did the orchestrator actually do? Did it do what our pipeline.yaml told it to do, or did it do something else, right? What configuration was that pipeline in when that build was executed? So these are all things that are very difficult to get access to, right? It takes a lot of manual effort to go in and look at those logs and see actually how that build and those tests were performed, right? The second problem that we've seen with our customers is inconsistent enforcement. You know, when I have to deal with a cybersecurity questionnaire on our products that we're delivering as a team, right? What I generally do is I give it to one of my engineers and say, hey, answer these questions for me and give me back this compliance report, right? This is repeated across every single piece of software that your bank brings in, right? So what is actually happening here is that enforcement of those cybersecurity controls are dependent on how well that engineer answers that questionnaire, not actually what the developers did for that software artifact, right? So we're placing trust in that person. And the enforcement is going to vary from team to team because it matters on that person rather than the actual process. So this all leads to manual compliance bottlenecks because we don't really understand if that artifact is compliant or not. So this forces us to go into more of a manual workflow where we're checking that evidence before we push the software into actual production. So how do we fix this problem? How do we solve this problem? Well, step one is we automate the collection of the evidence when we build the software or when we test the software, right? We can observe that test happening. We collect the inputs, the outputs, as well as the environment that test or that build happened in. And when we have this, now we have all this data in a schema. And because we have this data in a schema, it means we can develop a policy against it and we can evaluate it in a way that we never could with unstructured log output. And then, so number one and number two are what we've really been focused on with our open source projects, Witness and Archivista. And then number three is what we're focused on as a commercial organization developing a product under a commercial license, right? How do we bridge that evidence and the evaluation of the evidence with actual compliance controls that, you know, your executives and your organizations and your auditors actually care about? So this is the idea that we've come up with as a team, right? And it's the idea that we need more than just DevSecOps in order to ship product to market faster. We need to integrate product development with compliance. So we can only do this if we have reliable, trustworthy access to that data. So, you know, all of our business goals for our product, quality assurance, testing and evaluation, legal, compliance, regulation, security, human review, these are all the things that matter to determine the quality of our software as it relates to the markets that we want to put our software in. And this all stands on a foundation of provenance and attestation, as well as policy as code. So we can implement this framework with the in-toto specification and two tools that we've developed here at TestifySec, Witness and Archivista. Witness is your pipeline observer. This collects the information, collects the events that happen in your software development pipelines. This information is signed with a key provider and then stored in Archivista. Archivista has a GraphQL API that allows you to query evidence from your entire supply chain in one single place. So these two projects have been in use by some very, very large organizations for some time now. And we have some really great testimonials. In fact, Autodesk, they started a FedRAMP journey many, many years ago. But because they lacked the ability to centralize evidence within their software development pipelines, they weren't able to complete it. So a couple years ago, Jesse was looking at some of the open source projects that were out there, was looking at SigStore, and then eventually found Witness and said, hey, this is exactly what we need to do to meet our organizational requirements for the compliance controls required in our software development process. So talks about it a little bit right there, and there's some talks that he's also done highlighting the use of Witness and Archivista. Additionally, right, we've had a lot of success within defense and aerospace where, you know, that auditability and that traceability, those requirements are very, very similar to what they have in FinServ. So we've been helping Lockheed Martin with that, specifically with their open source program office. So a lot of other users, you can see some of the logos on the other side, right, that have participated in either the in-toto or the Witness and Archivista communities. So with that, I want to show you. We want to show you what this actually looks like in practice. Like, how do we validate a pipeline from end to end? And John's gonna show you that.
All right. Hopefully you can hear me. So this is one of the most commonly used diagrams about supply chain security. This is the threat model from SLSA, and it's on all sorts of different people's websites that have never shown up to a SLSA community meeting before, which is a different conversation. But you can see here they're looking at all the different problems, all the different threats. And so not only does every single process in the organization, as part of your delivery process, have a threat to it, but everything in between those steps. You really need to make sure that what is the output of one step is the input to the next step. And the other part about this and really the scope of what SLSA looks at is it misses a whole bunch of other things that are important. So we have a pipeline here just kind of as a sample. It's open source, you can see it. And this is, for us, a little bit closer to a more practical supply chain or CI/CD pipeline. Being able to do your formatting and linting and your unit testing and your static analysis, actually building container images, generating an SBOM. And this doesn't even include all the stuff with the red X's down here, which are also probably really important for things like SOC 2 compliance or SSDF or other things like this that you need to be doing. And the other reason for having all of this be verifiable is everybody lies. It might be intentional, it might be unintentional. I know there's a bunch of folks out there who have Confluence pages they need to update for their release process. I'm sure nobody's ever reused the screenshot of a pipeline passing in order to get the product out the door because of flaky tests or something like that, right? So this is mostly covered by what Cole said earlier, just a high-level witness being able to monitor whether it's the code repositories or your CI/CD pipelines, generating this evidence, storing it in Archivista. And then the other part of this is policies. How do you really ensure that compliance? And one of the other parts we talked about is in order to integrate across the entire ecosystem, all these different things that we need to be interoperable with, whether it's different mechanisms for signing and verifying, different standards for the content and the data of the attestations that are generated, and where those things happen, which CI/CD platforms. And so this is a great part about the open source, is there's a bunch of people with a bunch of different requirements who can come and contribute their own integrations there, and then everyone else can benefit from those. So we'll try and rapid fire go through a live demo. And let me just quickly show. So this is a code change in this repo to, it says we really do need root for this container image. And so we're going to add this in. There's some things we need to do to install some software or something else like that. And you can see when we submitted this PR, here's our full pipeline that we saw the screenshot of before. It failed almost immediately on this linting step because in this step we're using HaloLint that's going to find used root as part of that. So this is great. We give the developer feedback right away. What's the next thing they do? We're going to submit another PR. Prod is down. We need to disable linting. Rather than going back and fixing the container image, let's just get rid of this problem. So what we're going to try and do here is, we also don't have any branch protections here. So we're going to go ahead and just merge this ourselves. It's not really a big deal. Who really cares about code reviews? And our branch was deleted, so nobody will know we did this, right? And now everything will kick off again if we look at the actions, and we should see everything progressing further along in a second or two, or not. But really what we can end up seeing here is the linting step will pass. Once that happens, for the developer, they go through and everything else passes because it no longer detects that container image had root in it. And because of the ways in which the attestations are signed, we don't create the attestations on a pull request, but they get created on a push. And so we're able to see everything else going on here, but the verification doesn't actually run. And we can say for this, this part of the process, the developer doesn't really know, but as soon as we try to go to production or something else like that, now the verification fails. And we have two different verifications here. One, that there was actually a PR, and the PR had an approval, and the other part was that all these requirements throughout the overall process were complied with. And so since we did that last merge and we just put it straight into main, we really should have a PR, a code review for this next one. So I may or may not happen to have another GitHub account, and I can come in here and look at the changes. We put this ignore in here, which are kind of a big deal, but prod's down. I'm not going to be the person that stops everybody from going home on a Friday. Let me just go ahead and approve this. All right, and it looks like most of the stuff worked, so it should be pretty good. And we'll go ahead and merge it now that it's got an approval. All right, so now as this is coming through again, in this verify PR step, here we go. We should be able to just rerun the failed jobs and see what happens here. This might take a second. Fingers crossed for conference Wi-Fi and GitHub runners and everything else.
But it kind of brings home the point, though, right? If the test didn't run in your pipeline, how do y'all know? Like, do you have any sort of verification that a test was run and a developer didn't just disable it? What's that last check you do before going to production or before signing that attestation, that has actual real legal consequences to it, right? That the software meets your compliance requirements. Are you trusting everything that a GitLab pipeline or a GitHub pipeline that check runs because you told your developers to do it? Or are you actually validating the developers are doing what they're supposed to do on every single release, right? That's how you protect your organization from risk. And before the in-toto frameworks existed, before Witness and Archivista existed, these things were very difficult to do. There's a lot of organizations that are creating their own custom frameworks and code to do this exact thing, right? To collect that data on every single test, on every single PR, to have that centralized repository. In-toto and Witness and Archivista gives you the framework to do that with open source. That's licensed to MIT, and has that corporate support from TestifySec behind it.
Apache 2.
Apache 2, sorry, Apache 2.
So we can see here, this is our policy evaluation, and our verification failed still for our PR check, but the steps, we have all the different steps documented here. We can see the step for the pull request review was passed now. So you think everything is good, but in the end, the linting step is still failing because we don't have the right command that we're using. We've got that extra parameter in there to the CLI. So, all right, let's go and try to actually do this the right way. We can back all this stuff out, solve the problem in a better way. I'm going to need my helpful code reviewer again. We can see here from the set of changes, there's really not actually any changes because we're just reverting the other things. And we've got an approval. We can go ahead and merge this. And now as we come back here and re-verify Nope, not all jobs. That would. All right, so now this time we should see the linting step, and we did see we should see when this populates here. The linting step is passing because we'd removed that parameter as a part of this PR, but we also fixed the Docker file, so we know when the image is built, everything should be good. And the verification should only take a second here. And any second now. This will go through the same sort of process. And
so what Witness Verified is doing is it's reaching out to Archivist stuff that has that centralized store of all those attestations. And it's calculating the SHA-SUM of the artifact, whether it's a container image or a binary or anything, and using that as an entry point into a graph of all those supply chain attestations. And so it starts following the graph, following those hashes for all the inputs and the outputs for each step along the supply chain, and collects all those as candidates, right? And then we go through and validate the signatures, match the functionaries that are on our policy, right? These are the machines and the people that are authorized to perform the processes within our organization, right? So we validate that the right machine or person signed it. And then we validate that the inputs and the outputs of all the attestations are what we expect it to, right? So that means if we're running a scan tool that produces a SARF document, right? Now we can analyze that SARF document that says, hey, we want to make sure there's no highs or criticals, otherwise that's out of policy, right? So we can do this for any JSON document that's out there and evaluate that to make sure it's within our organizational constraints.
yeah, and we can see when we merge the PR, our verification is passing for the overall supply chain and for the PR itself. Now there's also going to be a build that kicks off for the push that goes to the main part, and we have the verify failed. This verify should work. And it failed for a linting step still, even though that was. But the
probably hit a race condition.
yeah. When it's working properly at the end here, when you merge a PR through GitHub, it actually does a new commit, right? So you take the code that was in the branch. And so the code review, the information you have points to the commit of the code that's on the branch. It doesn't point to what's on main or whatever the source is. And so after the merge happens, you get a new commit SHA. And so the PR verification fails because that PR is pointing to the old commit. And we don't have an entry point in the graph to the commit and all the information that we're gathering here. So throughout all these other steps, we're collecting information about the git commit of main at this point, or this branch. And when we look for that PR approval, it's not there anymore. We can't find it on the graph. But when we do the verification that includes looking for, in the policy, it looks for the pull request being merged, and we have the information about the commit SHA that matches up with main, then we can traverse on the graph back to the PR and find that the last PR approval is what was there for that commit. The same thing that this helps with is if someone decides to go and push commits over top of a PR and add new commits to it, the commit SHA will change again. So if there was previously an approval, that's essentially, if you have everything configured the right way in GitHub, it's dismissed. But sometimes people don't, and they can do stuff like add an outside collaborator from some random account and approve PRs. So yeah, this is kind of the overall demo of things. This is all public. You can see on github.com, TestifySec/SWF for Software Factory. And then we also have the, the details of the policy as well. It just enumerates the different steps throughout the supply chain that you expect. And then you can add as many details for the checks as you want to in here. And so for the linting step, we're looking for this rego policy, which is thanks to JSON, base64 encoded and everything else. But really what it looks like is just this pretty simple, we expect this to be the input command, which is -lint -f serif for our Docker file. We're not expecting that -- ignore command in here. So this is what fails. And then we have similar checks down here for the pull request review. Make sure that not only did we get a pull request review, but the state was actually approved. That's the thing we care about, not just that it exists, but that it's in the right state. So.
And I know a lot of frameworks, customers we work for, they want to make sure that their scan tools, their configuration doesn't change, right? That's one of the big things that the auditors look at. So Witness and Archivista, right, purposely built to make sure that the configuration for our tools don't change, as well as to centralize that reporting. So it can really help with a lot of those compliance controls that have been difficult to, to prove in the past. We now have that cryptographic proof behind those events that the developers ran.
Yeah. So that's everything. We got a few minutes for questions in case anybody has any.
Yeah, that was a good question. So what do I need to run actually on the side of my pipeline tools for this to work?
So we have GitHub Action. We also have a GitLab component. And generally, Witness is a CLI that just wraps around any command. Yeah. So it's about 1 or 2 lines of changes to every step in your pipeline. We're also working on integrating directly with different runners themselves. So you can essentially inject Witness in there to observe. We have it working more easily with things like Tecton, where we can just hijack the entry point for the container image. But we're also working with GitLab on the GitLab runner.